Now that we've studied proportions and ratios, we're ready to talk about and define similar polygons. Now, first of all, remember back when we talked about congruence. And let's suppose that there are two polygons and they're congruent. Let's suppose that these two polygons right here are congruent. Well, if that's the case, then each corresponding angle, is going to be congruent. So all these angles are congruent. Now, not only that, but each corresponding side. So, for example, this side would have to be the same length as that side, this side, and so forth. And 4. Okay, so that's what the situation would be if we were talking about congruence. But let's suppose we want to remove this condition that all the sides are the same. All the sides, each side is congruent to its corresponding side in the other polygon. Let's suppose we remove that condition and we just say the corresponding angles have to be congruent. Well, that's part of what's going to make a similar polygon. But here's what has to happen. The ratios. Notice, look at this line. AB, this right here. Notice AB. If you put that over its corresponding side, over here, EF. Notice BA over FE, okay? Make that ratio, and you get this first entry here. Now you notice that's equal to, if you take BC and put it over FG, you get the same ratio. Now if that happens for every corresponding pairs, then, and all the corresponding angles are congruent, an angle is congruent to its corresponding angle. If that happens for every angle, then you have a similar polygon. Then you say these two polygons are similar, and we would write it this way, using this little symbol right there. Okay, that's how we say congruent. Now, let's look at these two polygons here, and let's see if we can determine if they are similar. Now, we notice they have corresponding angles that are congruent. This one corresponds to that one. The double corresponds to the double, the triple. Yeah, so this right here, the angles match up. Now, we're curious about, the sides are certainly not the same, so these aren't congruent, but we're curious about the ratio. So let's look at some ratios here. Let's look at the corresponding sides. We've got 6 over 4. Okay, 6 over 4. Those sides correspond. Looks like 15 would correspond to 10. Okay. And then 12 to 8. And then 9 to 6. Now, I put equal signs in here, and I was a little presumptuous because I didn't really calculate what it was. But if this is true, if this equality holds for every one of these, then those two polygons are similar. So here we go. We got 3 halves for this first thing. 3 halves for the second. See, 3 halves, 3 halves. This one is, let me see, 3 halves. This one over here, yeah, 3 halves. Those two polygons are similar. And by the way, let me call this polygon X and this polygon Y. We say that the scale factor from polygon X to polygon Y is 3 halves. In other words, this common ratio that we get for each of these, we say that's the scale factor from, in this case, the big polygon to the little one. Okay, so now, so that's kind of how we're going to define similar polygons. Now, let me show you something interesting here. Here are 2 polygons, and they're similar. Notice 2 is to 4. Let me write that. 2 is to 4, what 3 is to 6. See? So the same ratio. This is 1/2, and this is 1/2. The angles are the same. We're assuming these are rectangles. So, and those are right angles. Now, notice this. The ratio there is 1/2. So 2 over its corresponding side 4, 3 over 6, and so forth. But let's look at the perimeter. So here we have 3, and here we have 2. So the perimeter here is 10. Maybe I shouldn't put that in there. That looks like an area. Let me put it out here, 10. That's the perimeter. Now let's look at this perimeter. This is 6 and this is 4. So this is 12 and 8. That's 20. Now let's look at the ratio of the perimeters, this perimeter to this perimeter, and we get 10 over 20, which is 1/2. Just like these. So here, this is what this theorem talks about. That ratio that you're finding is going to be the same with the ratio of the perimeters as well. So the ratios of the sides, it's going to be the same as the ratio of the perimeters.